Okay, in this video, I want to establish a formula for the derivative of the sine function, the derivative of the sine of x. And for this, we'll use the limit definition of the derivative. So, the derivative of the sine of x should be equal to the limit as delta x approaches 0 of the sine of x plus delta x minus the sine of x all divided by delta x. Okay, so now we can apply the sum difference formula for the sine function. And so we have this formula that says the sine of a plus b is equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. So we have this formula, and we'll apply this here. Okay, so that should equal the limit as delta x approaches 0 of the sine of x times the cosine of delta x plus the cosine of x times the sine of delta x. Okay, so that's the sum formula for the sine function. And then we have this minus sine of x here. And this is all over delta x. Okay, so let's rearrange the terms in the numerator, because we have a sine of x here and we have a sine of x here. So let's just put those two together so we can factor out a sine of x. Okay, so we have the limit as delta x approaches 0. So let's just switch these first two terms. So we have the cosine of x times the sine of delta x plus the sine of x cosine delta x minus the sine of x. Okay, so all I did was rearrange the terms in the numerator, and now we can look at these two terms and factor out a sine of x. Okay, so we have the limit as delta x approaches 0. And you know what, we could actually split this up into two fractions. Let's put the cosine of x times the sine of delta x over delta x plus, well, let's actually factor out you know what, we're going to factor out a negative sign. Negative sine of x, 1 minus, and if we factor out this sign, we'll have a cosine of delta x all over delta x. So we're taking the limit of this whole quantity, and the reason I factored out a negative sign is because we have these two formulas, these two limit formulas that we established earlier, these two special limit formulas, one for the sine, one for the cosine. We have the limit as, I'll use theta in the formula. Theta approaches 0 of sine theta over theta is equal to 1. And we have the limit as theta goes to 0 of 1 minus the cosine of theta over theta. This limit is equal to 0. Okay, so we have, this is a formula that we've established earlier, and so is this. And so we have this 1 minus cosine delta x over delta x. So the delta x is in place of the theta in this formula. And we have a sine delta x over delta x. So that looks like this formula. Okay, so we can apply those two limit formulas. So here we have the limit as delta x approaches 0. So the x here, so we have a cosine of x and a sine of delta x. This limit has nothing to do with the x. This limit only has to do with the delta x. So this cosine is not affected by the limit. So what we could do is we could put that cosine out front. Cosine of x times the limit as delta x approaches 0 of the sine of delta x over delta x. And then same thing here. This limit does not affect the sine of x because it doesn't contain a delta x. So we could subtract off the sine of x times the limit as delta x approaches 0 of 1 minus cosine delta x over delta x. Okay, so according to these formulas, this is equal to 1, and this is equal to 0. So we have the cosine of x times 1, which is the cosine of x, minus the sine of x times 0, which is 0. So our derivative is the cosine of x. Okay, and that's it. That's our formula for the derivative of sine. The derivative of the sine of x is equal to the cosine of x. And this is our rule for derivative of the sine function.